So let's start the class. Good afternoon, guys. Welcome to NEET World Institute and NEET World YouTube channel. Right. So I hope, this class is particularly for the EAPCET as aspirant of both NEET as well as medical as well as engineering. Sorry, like I have told NEET, it's engineering and medical streams for EAPCET. And we were discussing the topic laws of motion in the last class now. So now we will continue with the next topic of the laws of motion. Okay, so we'll wait for 1 or 2 minutes for the people who are joining over here. Okay. Yes, let's start. So laws of motion. So in last class we were discussing the topic like what are the forces or what type of forces are acting on a body, right? Like normal force, then weight, then tension, then what else? Frictional force. Yes, frictional force. So we were discussing how the forces will act and in which direction and how or when the forces will act. Everything we were discussing right now. So now we will move on to the topic. Equilibrium also has been completed, no? Yes. Now for example, let me take an object of mass m1 and another object of mass m2. Now suppose a force has been applied on a mass m1. Okay. Now what is the acceleration of the blocks? What is the acceleration of the blocks? In before cases we have seen that m1 was there and m2 also was there, and we were kept on a surface, right? Now yes, like we were discussing about and what type of forces are acting, right? Normal force will be there, here also normal force will be there, and one normal, another normal, so totally 2 normals, right? 1 2 3 4 normals are there, and the weight, yes, no, weight, that's it. So now everything are in equilibrium condition, like the object is at rest. Now object is moving because I have applied an external force F on an object, right? Now object is moving with some, yes, some acceleration. So what is that acceleration? We know that F is equals to mass into acceleration. What is the total mass? Okay, m1 plus m2. But the thing we should find properly over here, what are the forces are acting? I need to get it now. So free body diagram for f1. So m1. So m1 free body diagram. What are the forces? Yes, normal force is there, that is n1, and weight is there, that is m1g. So the thing, when I apply a force, object is going along with the surface, which means n1 and m1g will be equal, right? No, and another force is the normal by m2. So this is n, and force F is there in this direction, this is F, right? No, that's it. and acceleration which direction? In this direction is the acceleration. Now for m2 we will draw the diagram. So for m2 normal 2 is there, n2, and m2g is there. Now if I see the condition, m1 is there and m2 is there, both are attached. So because of m1 one normal will be there, this is n, that's it. And for this also acceleration is in this direction only. Now the thing is, I need to write that equations, right? Now here the sum of force in y direction will be equals to 0, because there is nothing movement in the y direction, only x direction the moments are there, right? No, so whenever we are having an acceleration, so the direction of acceleration, whatever the forces are there, take it as positive. Opposite direction of acceleration, take it as negative. So for the first block, in the direction of acceleration, f is there. So let me write f, in opposite direction n is there, minus n will be equals to mass m1 into acceleration a, that's it. Now for the m2 n in the direction of a, so n will be equals to m2a. So can I substitute, like I'll take this as equation 1, equation 2, I'll substitute equation 2 in equation 1, which means f minus m2a will be equals to m1a. So f will be equals to m1 plus m2 of a, will be nothing but a will be equals to f by m1 plus m2. Yes, no, the previous thing we have written here, f is equals to mass into acceleration. The mass is nothing but the total mass, right? So when I want to find the acceleration of the given block, so a is equals to the external force has been applied divided by the total mass, right? Yeah, you can take a note of this. We will see for the three blocks, next one, okay? Done. Can we move for the next one? Yes. So the next one is 3 blocks, m1, m2, m3. Now I am applying a force in this direction, F. Okay. Now what are the free body diagrams? So the free body diagram for m1, let me write here, this is my n1 and this is my m1g, right now. So m2 is the other surface having attached with m1, so there will be a normal force in this direction right now. So there is a normal force, that is n. So this is n1, let me take n1. Okay. Now next is m2. When I talk about m2, how many contact surfaces are there? Now I can freely say that no need to worry about that y, I need to worry about that x. Okay. So let me write that also. Okay, that this is the forces n2 and m2g. Due to m1, object normal force will be in this direction n. Due to m3, normal force will be in this direction, that is n dash. Okay. Now what about m3? M3 also is there. So m3 this is N3, this is M3G. Force is acting in this direction F. Due to M2, a normal force will be there, that equal and opposite force, no, this is N dash. So whenever an objects are attached, the internal force will be equal, right? Yes. So now let me write that equations. So object is moving in this direction, right? A. So for this also A, and for this two also A in this direction only. So A in this direction, no. So the normal force is also in the same direction. N will be equals to M1G. Not, yeah, N will be equals to M1A, right? No, not G. Yes. Now the next one is second one. In the same direction of acceleration, N dash is there, opposite direction N is there, should be equals to M2A. And the third one is F minus N dash will be equals to, what is that thing? M3A. Right? Now let me take, this is equation 1, equation 2 and equation 3. If I substitute equation 1 and equation 2, what will happen? Let me write over here. N dash will be equals to M2A plus M3, so M1A, right? Let me take this equation and substitute in equation 3, that is F minus F will be equals to M2A plus M1A plus M3A, which is nothing but A will be equals to F divided by M1 plus M2 plus M3. So whenever they are asking an acceleration, we got an equation, that is A is equals to F by the total mass of the system, right? Now let me write here, note point. Acceleration is nothing but force by total mass, that's it. So this is the conclusion we got from the last two problem, right? Yes, you can take a note of this. Yes, we will do a problem over this now. Can we go for the next one now? Yes. Now we will see a problem over here now. Okay. We'll see a problem. Okay. So the question is, there is a two blocks. Okay. One is 3 kg block and one is 2 kg block. Yes. Let me write that here. 3 kg and one more is 2 kg. Now two forces are acting, that is F1 and F2 in one direction, that is F1, and opposite direction, that is F2. So F1 is equals to 100 Newton and F2 is equals to 25 Newton. I need to find, yes, I need to find what is the acceleration. I need to find the acceleration. 100 and this is F2 is equals to 25 Newton. Need to find what is the acceleration. Fine, this is the equation. This is the equation. So what are the things are there? 100 Newton, 25 Newton. Obviously, 100 Newton, like let me write here, F1 is greater than F2, so object will go in this direction, so acceleration will be in this direction, right direction. That one I can say clearly, yes. Now, the thing is, 3 kg, this is F1 and opposite direction N will be there, the normal force will be there, right, and then acceleration is in this direction. So, equation will be F1 minus N will be equals to 3a, F1 minus N will be equals to 3a. So, this is my equation 1. When I talk about the free body diagram of 2 kg block, F2 is in this direction and N will be in this direction. So, this is my acceleration, N minus F2 will be equals to 2a. Two equations I got. So, I will write that equation, F1 minus N will be equals to 3a, N minus F2 will be equals to 2a. When I add the equations, N and N will get cancelled, F1 minus F2 will be equals to 5a, 100 minus 25 will be equals to 5a, which means 75 by 5 will be equals to a, and this 1 times, right, no, and this one will become 15 times, right, yes. So, a is nothing but 15 meter per second square is the acceleration. Now, suppose they are asking what is the normal force acting in between the blocks. So, I can take either any of this equation. So, F1 minus N will be equals to 3a, F1 is 100 minus N will be equals to 3 into 15. So, 100 minus 45 will be equals to N, where N is nothing but 55 Newton, right, no, 55 Newton, right. So, if I talk about N is equals to 55, when I talk about the second equation, N will be equals to 2 times of 15, right, no, 15 minus 25, so plus 25, no, plus 25. So, what is the thing, this is 30, no, 30 plus 25 will give us 55. Am I getting the same answer here? Am I getting the same answer? Yes. So, whenever they are asking to find the acceleration of the block, or else they are asking us to find what is the normal force in between the blocks, first try to understand, I need to take the free body diagram. So, take the free body diagram, understand the forces, whatever the things are acting on a given block, and try to understand in which direction the acceleration is. So, the direction of acceleration gives us the positive forces, in the opposite direction it will gives us the negative forces. Like positive force in the sense F1 is positive, opposite direction of acceleration given is normal, that is minus N. So, F1 minus N will be equals to 3a, right. Okay. So, this is how we will proceed to the problem whenever the problem is given in these types. Okay. Can you go for the next one? Okay. Now, we will see the blocks of 3, okay, 3 blocks. So, the given question is 12 kg, 5 kg and 3 kg, 2 kg, 5 kg and 3 kg blocks. So first one is two kg block, second one is 5 kg block, and third one is 3 kg block. Now two forces are acting in opposite directions. Okay, so one is F1 50 Newton and F2 is 30 Newton. F1 is equals to 50 Newton and F2 is equals to 13 Newton. I need to find the normal force between, let me write the equation. Find the normal force between 2 kg and 5 kg and 5 kg and 3 kg blocks. Next one is, this is first one, second one is find the acceleration. These are the questions. Okay, now can we see here F1 and F2? No, yes, F1 is 50 Newton, F2 is 30 Newton. Which is the greater thing? F1 is greater than F2, which means object will go in this direction, acceleration is in right direction, right? Let me take the block. So F1 is greater than F2, acceleration in this direction, right direction. Now we will solve the free body diagram. Okay, so the first block 2 kg. So what are the forces are acting? This is F1 and the normal force by 5 kg will be in this direction, right? No, so this is N dash and this is N1. So we want to talk about y-axis. Live. No need to talk about y-axis. No. Yes. So N1. That's it. Acceleration is in this direction A. Now the next block is 5 kg. So N1 is acting in, will be in this direction now, N1, and this is my N2 by block 3, N2, right? No, N2. Now acceleration in this direction only, 3 kg block. So F2 is in this direction and N2 will be in this direction, right? So now we solved the free body diagrams. That's it. We solve the free body diagrams. Let me write that equation. So F1 minus N will be equals to M1, that is 2A, and for this is N1 minus N2 will be equals to 5A, and for this one is in this direction acceleration. So N2 minus F2 will be equals to 3A. When I add the three equations, N and N will get cancelled, like minus N plus N, minus N2 plus N2. So F1 minus F2 will be equals to 2, 5, 7 and this 10A. So what are the things they have given? Forces, one is 50 and one is 30, no? So 50 and 30. 50 minus 30 will be equals to 10A. 20 by 10 will be equals to A. So A will be 2 meter per second square. So now we got the acceleration 2 meter per second square. What about the normal forces? Yes. Can I take this equation and substitute either in this three equation to get the normal forces? Yes. F1 minus N is equals to 2 into 2. So this is 50 minus N will be equals to 4. So N will be equals to 46. So this is N1, right? No, N1. What about N2? N2 minus F2 will be equals to 3 into 2. N2 will be equals to 6 plus 25, which is nothing but 31. So N2 is 31 Newton, N1 is 46 Newton. Right now? $25 only, no? Is this one? Okay, just 30. Fine. 6 plus 30 is nothing but 36. 36 Newton, not 31 Newton. It's a 25, not, it's a 30, no? Yes, I have written 25 there. So try to change this one, okay? Yes. So this is how we'll proceed for the 3 blocks. So once you have completed, we can go for the next. So that is a rope attached between the blocks. A rope attached between the blocks. Done? Okay. We'll go for the next one. Okay, fine. So the next one is, suppose this is the surface. Now the blocks are there. This is M1 attached with some rope M2 attached with again some rope M3. Okay, no need to talk about the two blocks. Now we'll talk about the direct 3 blocks only. Now external force has been applied to take the blocks in the right direction. So the acceleration will be in this direction. Okay, no? Right, now I need to draw the free body diagrams of M1. So when I talk about M1, what are the free body diagrams are there? So the normal is there, N1, and the weight is there, M1G. Now the tension is away from the body, no, away from the body. So T will be like this, right? No, and this is different rope. I mean, this is same rope and this different rope, right? No, one rope, 2 ropes. This is not a same rope, so tension will be different for this between and this between. Okay. Then when I talk about M2, so 2 ropes are there. One is T, the same tension will be there. Other one is T1. Now this is my N2 and this is my M2G. And when I talk about M3, so this is my tension T1 and this is my force F and this is my M3G. So these are the free body diagrams of the given block. Now if I want to write the things like the equations, I can take the direction of acceleration. This is my direction of acceleration. I need to find what is the acceleration, right? No, now I don't need to worry about the y-axis. I need to worry about the x-axis now. So T will be equals to M1A. Next, T1 minus T will be equals to M2A. Next, F minus T1 will be equals to M3A. When I add these equations, T1 minus T1 will get cancelled off. F will be equals to M1 plus M2 plus M3 of A. So A will be equals to F divided by M1 plus M2 plus M3. So what we can understand over here? Yes, whenever the blocks are in contact, we have applied a normal force. Whenever blocks are tied with a rope in between, we have taken a tension. But the formula we got, acceleration is nothing but F is equals to the total mass of the system, right? No, so no need to worry about whether it's a normal force or a tension force, okay, right? So whatever the tension force act by M2 on M1 or M1 on M2 will be equal, and whatever the normal forces are acting by M2 on M1, M1 on M2 are also will be equal, right? So we will get the same equation, that is A is equals to F by M1 plus M2 plus M3, the total mass of the given system. Done. Okay, now we will see problems now. Okay, we'll see problems. Guys, try to understand that whenever the ropes are given, no, it's a massless rope. We won't consider the mass of the ropes, okay. When they will give a mass, I need to consider it's a mass rope, okay. We will do a problem on this now. Listen, a 5 kg block as a rope of mass 2 kg attached to its underside, and a 3 kg block is suspended to the other end of the rope. So there is a rope, okay, there is a rope of mass, okay, let me write this. This is the rope, okay, of mass 2 kg, and upside of the rope one block has been attached, that is 5 kg block, and downside it is 3 kg block, okay, 3 kg block. This is the given question. The whole system is accelerated upward, the whole system accelerated upward with 2 meter per second square, 2 meter per second square by an external force F naught, by an external force F naught, by an external force F naught. So some F naught has been given here. So find what is F naught. Find what is F naught. This is one question. The second question, let me read it. What is the force on the rope? What is the force on the rope? What is the force on the rope? Third question is, what is the tension? What is the tension at middle point of the rope? What is the what is the tension at middle point of the rope. These are the three questions given, and this is the diagram also. Now I need to find what is the forces. What is the forces? Any idea? Yes. So when we are talking about the mass rope, I can consider this as a block. I will consider this as a block, okay? Or let me consider, let us consider this as a block. Okay. Now it will be easy to find the answer for the given question right now. So F naught is given. What we can understand over here, blocks are there. The total block mass is given as 3 kg plus 2 kg, 5 kg, 5 plus 5 is 10 kg. So 10 kg, upward force is F naught and acceleration is A. Don't blindly take A is equals to F naught by M or F naught is equals to M into A. Okay, don't take blindly, because when we are talking about this problem block is going upward direction in y axis. I need to consider whatever the forces are in there in y axis. So if I talk, the weight also there, 10 g will be there. Okay, 10 g will be there. Now can I say that F naught minus 10 g will be equals to 10a, right? So F naught will be equals to 10 into 2 into plus 10 into 10. So 20 plus 100 will give us 120 Newton. So 120 Newton is the force of the total system. 120 Newton. This is the answer for the first question. So second question, what is the force on the rope? What is the force on the rope? So force on the rope in the sense, F is equals to mass into acceleration. Mass of the rope is 2 and acceleration is 2, so it is 4 Newton. Only force on the rope is Yes. So third question is homework. What is the tension at the middle point of the rope? What is the tension at the middle point of the rope is the homework for you. Okay. So this one is homework, this question. Third question is homework. Need to complete. Okay. So we will see the inclined plane now. Inclined plane. What happens for the inclined plane and how can I take the components of the inclined plane? Okay. So when I talk about the normal surface, a block is there. So this is M1. So I can say N and this is M1G. So N will be equals to M1G. But whereas this is my inclined plane of angle theta, this is my block M, this is my N, right, and this is my W, that is M1G or Mg. So I can say that N1 is not equals to M1G, right. So whenever we talk about a normal plane surface, N will be equals to M1G, but when I talk about an inclined plane, N will not be equals to M1G, because both are in the somewhere like different directions, right. But I need to take the component and I can equate it right now. So how to take the components of the inclined plane? So let me give a simple trick over here. Take 8 divisions, like this is 1, 2, 3, 4 divisions. So when I take like this, 1, 2, 3, 4, 5, 6 division has came, and when I talk about one more line, yes, 1, 2, 3, 4, 5, 6, 7, 8, 8 divisions came. Now let me consider this is my theta. So leave alternative space. So again theta over here, theta over here, theta over here. Okay. Now these are my thetas. So I will place this here as it is. I will place this triangle as it is wherever it fits. Okay. I will place here. Now this is my M, no, sorry, that is M1G, no. This is my M1G, and this is my N, no, according to the diagram. So the M1G is there, right? M1G is there. I can write this as, whenever the angle is close to the theta, axis is close to the theta, that is cos theta, M1G cos theta, and this is my M1G sin theta. I can either take the component of this or else I can take the component of this. So this one will be my N1 sin theta, or the N sin theta, cos theta, and this one will be my N sin theta, cos theta, sin theta. I will talk about M1 also, so no issues, right? So now I can say that, this is my block, and this is my N, and this is my M1G cos theta, and due to M1G sin theta, the block is coming down. Now what is the acceleration of the block? So this is my acceleration of the block. I know when there is an inclined plane or declined plane, no, the angle has been made, right? So obviously due to the gravity it will come down. But what is the acceleration? So F, this is the force acting, no, M1G. Can I say M1G sin theta will be equals to M1A. That's it. M1 is the mass, M1G sin theta is the force acting in the direction of acceleration, M1G, no other forces. So will be equals to M1A. So now M1 will get cancelled. A will be equals to G sin theta. So whenever we talk about inclined plane attached with n number of masses, acceleration is independent of mass in the inclined plane. A is directly proportional to G sin theta, and depends upon theta only A varies. Depends upon theta A varies. Okay, this is the thing we can understand from the given conclusion. Okay, no? So you can take a note of this. We will do problems in the upcoming classes. Okay. So with this I will conclude today's class. Okay. Yes. Yeah, this is like when I talk about another block, yes, another block that is M2 or another block M3, the total acceleration will be depends upon angle theta only. So A will be directly proportional to theta. If theta increases, A also increases, right? A also increases, because sin theta, trigonometric values, the theta increases means the value also increases, like 0 to 90, 0, 1 by 2, 1 by root 2, root 3 by 2, 1, right? So 0 to 1 we are going, obviously the values are increasing. So if the values, theta increases, A also increases. Okay, no? Yes, fine. So with this I will conclude the class today. Thank you guys. We'll meet in the next class.